Hi guys, today I'm going to teach you how to configure Ospf over a rame-relay network. I'm going to also teach you how to configure your router via rame-relay switch. This is a view of the topology, but we're actually going to do live Cisco equipments. So we're going to start off by configuring the rame-relay switch, which is going to be router 3. So we start off by going to global configuration and do the command rame-relay switching. That will activate rame-relay. And then we go into the interface of 0/1, which is New York, 1/0, do the encapsulation, rame-relay, and we'll put a clock rate because we are the service provider. And then we do the rame-relay interface type, which is going to be the DCE. So since we're going to be the DCE on that link, then you're going to be the DTE. So let's configure the Delta numbers. So we're going to do the command rame-relay route, specify the Delta number, which is going to be 100. In other words, which interface should it point to? So on this topology, you can see Delta 100 should go out to Delta 202, which is going to be on the link of 1/1. So we're going to specify the link, which is going to be the serial link of 1/1, and the Delta number, which is going to be 202. And it's the same thing. Rame-relay route. We're going to specify the Delta number, which is going to be 102. Go into the interface of serial 1/2. Sorry. And the Delta number, which is going to be 401. So put the clock work. We put the clock rate. I think we did put the clock rate. And we do a no shut command. And then we go into the other link, which is going to be 1/2, which is France. And we do the same exact thing, which is rame-relay interface type, which is going to be the DCE, encapsulation, rame-relay, clock rate, which is going to be whatever clock rate that's handles on the link, and specify the route. So in this case, we're talking about France, which is going to be 401. Go into the interface of serial 0/1/0. Delta number is going to be 102. We do the no shut. So let's configure the link for LA, which is going to be 1/1. Encapsulation, rame-relay, interface type, rame-relay, interface type, which is going to be the DCE, clock rate, and we specify the route. Rame-relay route is going to be 202, going to the serial interface of 1/0, with a Delta number of 100. And that's it. The rame-relay cloud is configured. At this point, with multi-point, we do an inverse ARP, so the Delta number is going to assign to each DTE interface dynamically. So if you go into router 1, and go into interface 0/0/0/0, encapsulation, rame-relay, this is shut down, do a no shut. So we do the command to see what Delta is on our interface, which is going to be show rame-relay PVC. As you can see, I have both 100 PC Delta and 102 Delta, and it both is active, which is good. You don't want it to say deleted. That means the Delta number is not configured properly. So inactive is also okay because it's in a state where it's going to be from inactive to active. But you never want to see delete status. So that's it. So let's configure the IP address. So we have a 192.168.0.0/29. That gives us an IP address of 6. 8 would be broad. 6, yeah, that's right. 7 is going to be broadcast, and 8 is going to be network. So let's do the interface, which is going to be show config t interface 0/0/0 IP add 192.168.0.1/29 equals to 248. But then also put the loopback 0. It's going to be 1.1.1. It's going to be a mask of /32. And we'll also put loopback 1. It's going to be also a mask of 32. All the links, loopback address is going to be a mask of 32. Oh god, no IP domain. Just look up. Sorry. So we have configured the IP address. We have assigned the appropriate Delta numbers by the frame relay switch. So let's go to router 4, which is LA. Let's show IP interface brief. And let's go into 0/0/0 link. Config T interface 00/0/0 encapsulation. You have to do encapsulation frame relay just to specify the encapsulation type. So do IP add 192.168.0.2. We're doing a /29. Let's do a shut, and no shut. And we should have Delcy 202 on our interface. Please remember the command show frame relay PVC because it's going to help you in your CCNA exams. It's a very important command. So show frame relay PVC. As you can see, we have an active Delcy 202. And so let's try to test for connectivity. So let's ping New York. And we didn't have a successful ping. Sometimes it does take a little while for it to sink in. As you can see, it's working now. So let's try again. Successful. So don't be too jumpy and think it's not working. This has to do with a little thing behind the scenes for it to work. Basically, it does inverse ARP. It maps the IP address to the Delcy numbers. So that's that for that. So we configured LA. Let's configure France. Let's do show IP interface brief. So let's go on an interface of 00/1/0 encapsulation frame relay IP add 192.168.0.2.3. Sorry guys. Oh brother, that's way off. That's wrong. Subnets. No. Let's do a shut. And no shut. So in this command, on this interface, we should have the 401 Delcy. So 401 is supposed to go to Delcy 102. As you can see in the frame relay switch, you go in the frame relay cloud, and do show frame relay, or do show running config. Sorry guys, show running config. Pipe begins with frame. And as you can see, from 1/2, 401 destined to 102. The serial link of 1/2. Alright, so let's go back to router 5 to see our command. Remember, show frame relay, PVC. And we do have the DLC numbers, and we can see we have packets going out and coming in already. So we should have a successful ping one shot. Successful. So show IP, brief. Let's configure the loopback address, interface, loopback 0. IP add is going to be 10.5.0.5.255.255.255.255. And this is incorrect. It should be 5. And there we go. So we have our loopback show IP interface 3. Okay, that's good. So now let's let's go back to router 1. Ping 192.168.0.1.0.2 and 0.3. But can we ping the loopback behind it? So no, we can't. All right, so we're gonna put in we're gonna turn on Ospf routing protocol, and we do that by typing router Ospf1. For frame relay, we have to put in a neighbor statement because it's an NBMA. That means it doesn't support broadcast, so we gotta do the neighbor statements. We're gonna send unicast traffic to each neighbors for it to actually work. So we do neighbor 192.168.0.2, which is going to be New York neighbor, and 3 is going to be France neighbor. Okay. For LA and France, you don't have to put the neighbor statement. You just got to go in and do the regular router or OSPF. The network is going to be 192.168.0.1. Gotta put a broadcast wildcard man 0.0.7 error 0. And if you actually do this and you see where you're not getting adjacent, just wait for like a good minute and a half or 2 minutes, because it's gonna take a while before it to actually form adjacency with New York to LA and from France to New York. So it's not like it's not working, but it does take a long time because of the frame relay cloud. So other network is going to be the 44.4.4.4. Is it 44.44.44.4? It's going to be advertise all these. And so it's 2 out of 5. Oh shoot. I forgot to actually specify the neighbor, but I didn't specify which area the neighbor is. So we're going to go in our interface of the serial 0/0/0. and do IP Ospf 1 error 0. And as I said, it's not going to form adjacent real quick. We just got to give it time. So let's go to router 5 and do the rest. So it's going to be router Ospf 1 network 92.168.0.1. And network, it's going to be the broadcast 10.5.0.5, the wildcard mask of 0. Wildcard mask is just the opposite of the subnet mask. So basically, all the zeros, each zeros is telling you like advertise the 5, the 10, advertise. Second zero says advertises the 5, and the third says advertise the 0, advertise the 5. So it says look at all this and advertise it out on your 0 network. So now that's done. Let's see if we actually have adjacents from LA to New York. Still haven't got adjacents. Let's see if I put the neighbor statement for router Ospf. Neighbors 192.168.0.1. Alright, so let's double check to make sure everything is okay. So we specify the network for both the 10 and the 198, so that should be good. All we gotta do is wait for Ospf to do its magic. Let's do a debug IP Ospf. Oh, there you go. There you go. So it actually take that long for it to form adjacency with the link. So if you go to show IP route, you see the IP route. Let's do the loopback of 0. So I advertised the network statement, but I haven't created a loopback for the IP address for the loopback. That tells you that even if you specify the network, if the IP address is not there, it doesn't even matter. It still won't populate because it's not there. So okay, so my neighbor statement is good. So show IP route. And now you see we have learned via Ospf. So let's go on this on a high level. So the O represents Ospf, open shortest path first. And this is a network that is learned via the routing protocol. This is the administrative distance. This is the metric that is used, which is cost. This is the cost. So, and this is the neighbor that it learns the network from. So it's telling you I learned this from the next up IP next up IP address of 192.168.0.2, I learned it from my interface, which is 0/0/0. So that's cool. So France, let's do a show IP route. So as you can notice from router 4, show IP route, we haven't seen these guys advertised to LA and New York and France because I didn't put a neighbor statement. So I have to put router Ospf1 network is going to be 1.1.1.1. Wildcard mask is going to be all 0 and it's belong to area 0. Network is going to be 11.11.11.1. Wildcard mask is going to be all 0 and it belongs to area 0. So since we speak OSPF on these loopback addresses, now if we look at router 4 and router 5, it should come up in our routing table. Should, but we're not seeing it. Interesting. Very interesting. Show IP route. So it's learned by router 4, but I guess it hasn't reached router 5 as yet. Or show IP OSPF neighbor, and that is the case. So we really don't want the DR and BDR participation on these links. So let's go in the interface of interface 0/0/0/0. Is it 1/0 IP OSPF priority? Priority IP OSPF PIO priority 0. Let's go into router 4. Go on our interface, which is going to be 0/0/0 IP OSPF PIR. It's going to be 0. Now, to show IP route, to show IP to show IP route. Alright, so let's look at router 5. Show running config. So we did do the correct thing. So show IP route. Let's do show IP. All right. Show IP route. So yeah, so now we have all the routes coming in. So it does take a little time, as I tell you. It's really slow via frame-relay links. So the next step is to actually see if we have connectivity to all the loopback addresses. So we're going to start by pinging LA loopback, which is good. And the 10.6.0.6. Sorry, wrong one. 10.5.0.5. That's also good. So let's configure error 1. The network statement is going to be 192.168.0.8. Let's go on that link of router 6. Router 6 is going to be the link 1. IP add is going to be 192.168.0.10. We're going to start doing a /30 mask. So let's go back to router 5. Configure its link, which is going to be the /0/0 IP add. It's going to be 192.168.1.9. Do no shut. Then we go to the router Ospf 1. The network is going to be 192.168.0.0.8. Area, all the wildcard masks is going to 0.0.7. Error 1. Should have fast JSONs because we're on broadcast. So let's ping 192.168.0.10. So we'll show IP interface brief. That's good. So router 10, router 5 interface 50/0 has that IP address, which is good. And then router 6, so it'll be having interface 50/0 unless we add the wrong IP address on the interface, no IP add. Let's change that to no IP add and go back to 50/0. Sorry, 0/0/1. IP add to the 192.168.0.10. Switch up. That's very interesting. So that's very, very interesting. Let's check router 5. So we're not getting anything from router 5 to router 6. Mm-hmm. So router 5 length. That's where that's 0 is supposed to be at. Correct. This guy. Unless the subnet mask is incorrect, let's do a show IP interface fast0/1. Mm-hmm. Well, it's not incorrect because we're doing /30. This should be working. So we're probably going on here. What's going on? So that's my interface. 10. It should be going to 9. Left. The router 5 pin is on interface. So router 5 pin is on interface. Let's shut down interface of router 5 with fast0/0. Shut. Do a little shut. And then add 192.168.0.9. Well, the subnet is correct because after 8 would be the network for this guy. 9 would be the first IP address for this link, and 10. So I know for a fact that's right. So let's see what's the difference from me shutting down the link. Sure. So it has the MAC address of 10. So that's interesting for you to have the MAC address but not pinging. So now it's pinging by just shutting down interface. So that's some form of bug in the Cisco iOS, or it's just what happens. That's good because that's why I like using the real stuff. Because stuff like this in Genius 3 will never happen. So you have that because you have the little issue sort out. So do is show IP Ospf neighbors. With my neighbors 10.5.0.5. Sorry, show IP Ospf neighbors. Says my neighbor is actually okay. So let's do the loopback. Interface loopback 0. IP add gonna be 10.6.0.6. And let's advertise this on the routing table. So let's give us an Ospf. Let's do this. Give us a network statement of 10.6.0.6. Wildcard mask of area 1. And let's see how fast it populates within the frame relay network. So IP Ospf routes. The intra error is there. Let's do it for IP route. So you can see it's learned by Ospf by intra error. You see the IP address it's learned from. So we have all our routes populating within the network. So let's see if we can ping from this guy, which is LA, to France loopback, which is going to be 10.5.0.5. Let's see if it's actually getting there. Let's do a debug. IP ICMP. So let's try it again. So it's not getting there. So let's try debug IP ICMP on the hub. Because it's supposed to go to the hub forward it back to this guy. So let's do it again. Nothing. As I said, because this doesn't support broadcast, we gotta do additional configuration. So we're gonna go in a frame relay router 4, and we're gonna go in the interface of 00/0/0, and we're gonna do frame relay route. Jesus Christ. Frame relay route to the frame relay app. Specify the destination, which is going to be 192.168.0.2.3. We're going to do broadcast. Yeah, 192.168.0.3. The LC number is going to be 202. It's going to be broadcast. Yeah, we got to do the same thing. We're going to be frame relay. We're going to go to the interface. Do frame relay map. Protocol is IP. put the IP address in for LA, which is going to be 0.2. The DLC number, which is going to be 401. It's going to be broadcast. So let's go back to router 4 and try to ping. We're going to get successful ping because we specified this link as a broadcast link. So now we're able to ping everything within the network, which is going to be like for 10.6, 10.6, 0.6, successful. So you see we ping from LA all the way down to France 2, which is good. And we can ping 5, 0.5. It's also good. And this guy can do the same thing. 44.44.44.4. Successful. We ping 11.11.11.1. Successful. So we have successful communication within each links. Tired, but let's go to router 6, router 2. They have a serial link. We're going to advertise Eigrp in this link. So let's go by router 6 and go into this interface. This is going to be 0.0/0/0. Encapsulation, PPP. IP add is going to be 192.168.0.13. No shut. We want to specify who's the DTE from who's the DTE, so we can know who's doing the clocking. So we could do that by show controllers and specify the interface serial 0/0/1/0. Sorry, 0/0. And we could look throughout this, and this will tell you exactly what we're looking for. Let's go back here. And this is what I'm looking for right here. It says DTE. The router 6 is the DTE. Router 2 is going to be the DCE. So router 2 is going to be the clock. Do the clocking. It's going to be the clock rate. 128. Encapsulation. PPP. IP add is going to be 192.168.13, 14, 255, 255, 255, 252. That is 0. I need to really need my coffee, man. So let's see if we have a successful ping across from router 2 to router 6. Mm. 168.0.13. Show run. It's good. Oh, I see, I see. This is there. So interface 0/0/0/. 0, no PPP authentication shaft. Let's go on router 6 to see if it has no PPP. Let's try to ping again. 192.168.0.13.14. Successful. Show running config. So let's do router EIGRP 100. We're going to specify the network statement was in 192.168.0.12. No order summary. Router Ospf EIGRP 100. Network is going to be 192.168.0.12. No order summary. And we have adjacents. This is also incorrect. We should be having EIGRP authent MD5. So let's go back and configure that. So let's also configure the loopback of router 2. We'll do show IP interface brief. Is the loopback there? Nope. Interface loopback 0. IP address going to be 2.2.2.2. So go back out router EIGRP 100. Network is going to be 2.2.2.2. And if we go back to R6, show IP route, we see the 2.2 network learned by EIGRP. If you look in the table right here, it says EIGRP alert. Whenever you see a D, it's learned by EIGRP. So let's do the authentication for EIGRP. I think I forgot it. It's got key chain. Specify a key chain, could be any name. You can just do lab and the key string, the key number 1, and the key string. We're going to do Cisco. So we configure that. Let's do a show and config. Type begins with key. Begins with EIGRP. Alright, so let's look for this command show running config. So lazy. Shortcuts sometimes become the longest. This is what I'm looking for. Do a quick copy and paste. into router 2. And how to activate the authentication. We go on the interface of where the link is speaking Eigrp on, which is going to be the interface of 00/0/0. We're going to do IP Eigrp. Is it Eigrp? IP Eigrp. IP authentication. Okay. IP authentication, which is going to be the mode. It's going to be Eigrp, the number. It's going to be message digest. And as you see, we lose the adjacency right away because we start speaking the authentication on the Eigrp. So IP authentication keychain GRP. For the number of the keychain, which is, what did we use for the keychain? Lab, I think. Is it? Let's see. All right. So yeah, it is lab. So as you can, if we do debug IP Eigrp and let's do neighbors or notification. Let's do notification and see if we get anything out of it. Not see anything for notification. Let's do neighbors. All right, let's do debug IP Eigrp 100 notification neighbors. So further, we're not getting anything. We're not getting anything at all. So let's go back in the interface. 0/0/0 IP authentication. It's going to be mode, and it's going to be Eigrp 100. What else? Message digest. And let's specify the keychain for the link. It's going to be IP Eigrp IP authentication keychain. It's going to be lab. Eigrp 100 lab. And we should have the link up back. There's new peer adjacency up. That's good. So our lab, we just completed authentication within Eigrp. What about we actually show IP route? Show IP route. Let's go to router 2. Show IP. Show IP route. So you can see my Eigrp that I've learned. So let's go back and you know what? Should I do it? All right, let's do this. Let's actually take the ERGRP route and inject it into the OSPF routes, and do vice versa. Take the OSPF route and inject it in the ERGRP. So we gotta go do that from right here, from France interface, which is gonna be show. Go to router 6. Shoot, I hate this shit, man. Come on. I need to finish this. Ugh. Sorry, guys. What the hell is going on? Alright, so let's do this. Let's do our show IP interface fast 0/0. Let's configure router OSPF. We also have 1. Redistribute. ERGRP 100. Metric is going to be 175. Let's do. Is it subnets? Metric 177. Oh, that's it. So we redistribute ERG to subnet and give it a metric of 177. So if we look at router 1, I think we should be seeing that 2.2.2 that we have learned via redistribution. As you can see, it's right here. Which is an external type 2 route. So we learned it via redistribution. So let's go back into router 6 and do show IP interface 0/0/0/0. Protocol that. Show and do config T router EIGRP 100 redistribute OSPF process IDs 1 metric. It's going to be bandwidth of the serial link. So the serial link is 1544. The delay is like 20,000 or 200,000. 2, 3, 4. Let's just copy and paste this shit before I make a mistake. And reliability, I think, is 1. Let's look. The reliability is 255. TXO is going to be 1. And MTU 800. Alright, so if I do this thing correctly, I should go in the router 2 and see all the routes learned by redistribution of Ospf. So show IP route. As I said, if I did this correctly, you should see a route. And there you go. So our job is complete right here. We have all the routes learned by redistribution within Eigrp and via Ospf. Let's ping for connectivity for one more last time. And successful to New York. And let's do LA. So issues here. You're not seeing LA. This is 44.44.4, yeah. Now it's working. Because I did a typo. And let's ping France, loopback. And it's going to be 10.5 and 0.5. And that's it, guys. We have our frame relay switch working. We got our Ospf working within the frame relay. We got redistribution working via Eigrp. We have authentication within Eigrp. Thank you for watching. Enjoy the rest of your day. This is Jermaine Baron. Until I see you next time, go Cisco.